Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 7.6 on factoring trinomials of the type that have a leading coefficient that's something other than 1. On our previous video, we learned about simple factorable. These that have a leading coefficient that is something other than 1, we actually call complex factorable. So as a shortcut here and out, you might hear this phrase complex factorable used to describe this type of factoring, this type of trinomial. Okay, let's take a look at an example here where we're going to actually just kind of do this by greatest common factor first. This is kind of a simpler way to do this. Now, they all can't be done this way, of course, but you always have to try this way first. As a matter of fact, the first thing you should always look for when factoring a polynomial is see if you can reduce it by factoring out a greatest common factor. So for these three terms here, 5x squared plus 15x plus 10, of course, our greatest common factor is 5. That's going to leave me x squared plus 3x plus 2. Now I have to see if I can factor this again using our simple factorable method. Okay, so x squared plus 3x plus 2, I know I'm going to want an x here and here, and I need a pair of numbers that multiply together to equal 2 and add together to equal 3. Well, with our luck, 2 is prime, so there's only one pair of factors, 1 times 2. And those two add together to equal 3. So this is the complete factorization of the original trinomial here. I would say one of the most common mistakes when my students do this is they leave off the first step. They leave off this first factorization. Okay, but that's part of the final factorization. So please be careful that you don't leave that off in your final answer. Okay. Now, let's take a look at what happens here when we multiply. This is just kind of a quick analysis of what happens when we multiply together two binomials that don't start with x and x. Okay, so 2x times 5x. So I'm going to actually write it that way. 2x times 5x plus the 2x times 1 plus 5x times 3, 3 times 5x, so 5x times 3, and then 3 times 1. Okay, so you can see what's happening here is that each of these appear twice. 2x appears here and here, and then 5x appears here and here. The 1 is here and here, and then the 3 is here and here. So when we do this type of factorization, we have to kind of come up with factors that will work in two different cases. It has to work here, and it has to work in combination with this one, in this case, the 5x and the 1. So it's a matter of kind of guessing and checking. But as you do this, you're going to get better at it. So let's look at some examples here. And the first one says factoring when a times c is greater than 0. So 4 times 3 is positive, right? 3 times 2 is positive. In this case, we have this negative b term. In this case, we have a positive b term. Well, the first thing we want to do is try, we're going to actually basically kind of guess and check. So this is how this works. And I've done this many years now, and to me, this is the best method. You're going to see all kinds of charts and boxes and things like this. To me, this is the best way to do this. And it is guess and check. It doesn't always work, so you're going to have to try a couple different ways. So 4x squared. So we can factor this into 2x and 2x, right? 2x times 2x. And over here, 3. Well, this is prime, so that's going to be easy. 3 times 1. And I list it this way for a reason. And this is the reason. Well, what we're going to do is we're going to cross multiply this way and this way. 2x times 1 equals 2x. 2x times 3 equals 6x. Now, does that add? We want to add this up. We want to add this up to equal this middle term. And this does not work. This does not work. So we have to do it again. Okay, so another way to look at this is, now you'll see this only gets me 8x, and that's not big enough. This 13x is kind of big, so we need to kind of increase our factors. We can't change this one. We can only change this one. So I'm going to erase this and start over again. Hopefully you got that in your notes as an example that doesn't work. My only other option over here is 4x times x. And again, this will be 3 and 1. Now, if I multiply this again this way, I'm going to get 4x and 3x. So now I'm down to 7x. So what can I do? That's not going to work. I'm going to switch these. And again, as you get better at this, you'll see these things happening because you'll know the 4 and the 3 is going to get you a 12x. You're trying to get a bigger number in this case. 1 times x equals x. So if I add these up, this equals 13x, which is what I want. Okay. So now that we've got these numbers in place, what do we need to do? Well, since everything's positive, these are my factors this way. Don't follow the arrows when you write your final factorization. Work across. So my factored form is 4x plus 1 times x plus 3. Okay? That's my factored form there. Let's take a look at the second example. The second example is actually easier because 3 is prime and 2 is prime. So it's only really a matter of matching up the pairing them up in order. So 3x times x, that's all I can do there. Now over here I have 1 and 2. I can go 1 and 2 or 2 and 1. I'm trying to get -7 here. So I'm going to try and put the bigger number here. Try it this way. So if I multiply this way, I'll have 6x. This way, I'll have x. Okay, let's talk about positive and negative numbers here. In order for me to get this to add up to be a -7x, this has to be a -6x, this has to be a -x. How do I make that happen? Well, I have to make 3x, this is positive, these are positive, right? 3x times -2, x times -1. Okay, so that's going to work for us. 3x times -2 will get me -6x. X times -1 gets me -x. And again, we group these this way. So I have 3x minus 1 and x minus 2. Okay, so we have to check those signs. And again, this is, I know it sounds a little complicated, but once you get this, it's going to be real easy for you guys. When the middle term is negative, what are we going to do? Well, again, we're kind of lucky here that the guesses are kind of limited because this is prime. So 2x times x, and then 7 and 1. So you can look at this and say, well, if I put a 7 here, that's going to be a 14. So let's put the 7 up here, and then the 1 down here and see what happens. Okay, so I've got 2x times 1 equals 2x, and x times 7 equals 7x. Okay, so in order to make this come out to be a -5x, I've got to make my larger one here negative. I want to end up with a -5. So I need to make this a negative and this a positive. That gives me a -5x. That means this number has to be negative. X times negative 7, negative 7x. This one has to be positive. 2x times positive 1 is a positive 2x. Okay, so in this case, I'm going to have 2x minus 7 times x plus 1. Okay, like I said, it's a little, once you get used to this, it's going to be a little bit easier for you. Okay, when A times C is negative, so this is a positive, this one's negative. So in this case, we're going to have to factor out a -1 first. Okay, we want to work with positive numbers. We'll factor out a -1. That leaves 4x squared plus 8x minus 5. Okay, and then we can try factoring. We can try 2 times 2 or 4 times 4. 2x times 2x, and then 5 and 1. That gets me a 10. Okay, 10 and 2 will get me an 8, right? So this gets me 10x. This gets me 2x. And I want to have a positive 8x. So this one's going to be a positive 10 and a negative 2. That gets me a positive 8x when I add them up. I mean, this will be positive. This will be negative. So my final factorization of this trinomial will be -1 times 2x plus 5 times 2x minus 1. And again, don't forget to include that original factor, the first GCF factor that we factored out. That's going to be people's most common error here. Okay, I want you to try these, factoring these on your own as part of your notes. Pause the video, work on them, and when you have answers, then you can move the video forward. Okay, so pause it now and work on them. Okay, did you get them? These will be your answers. If you didn't, go back and see what you did wrong and see if you can figure out your error here. Okay, that's it for now. I'll see you in class next time. Thanks a lot and have a great rest of your day.